This is Climate Watch. I'm Zhao Ying. Welcome to the show. Meteorologists have confirmed that an El Nino has formed in the tropical Pacific, and forecasts suggest it could intensify in the coming months. The U.S. National Oceanic and Atmospheric Administration says there's a 63% chance that sea surface temperatures in the Nino-monitored region of the Pacific could rise more than 2 degrees Celsius above average, making for a very strong El Nino. Some models go further. The European Center for Medium-Range Weather Forecasts suggests Pacific temperatures could climb by more than 3 degrees Celsius, potentially shattering historical records. El Nino is a naturally occurring climate pattern that emerges every 2 to 7 years, when weakening trade winds allow warm water to expand across the tropical Pacific. A strong El Nino can increase the risk of droughts, floods, heat waves, and disruptions to water and food supplies in different parts of the world. UN Secretary-General Antonio Guterres warned that El Nino will pour fuel on the fire of a warming world. China's National Climate Center expects the effects of this El Nino to peak in autumn and winter before gradually weakening next spring. How likely are we to see a super El Nino this year? How might it shape global weather patterns, and what could it mean for China? Joining us now is Wang Chunzai, a researcher at South China Sea Institute of Oceanology under the Chinese Academy of Sciences, and he is also the director of the State Key Laboratory of Tropical Oceanography. Professor Wang, it's great to have you with us. Scientists have declared that El Nino has formed. What does this mean scientifically? What exactly is El Nino, and what does that matter for weather around the world?
Scientifically, El Nino has formed mean tropical Pacific Ocean atmosphere are still in warm phase of the answer. This usually involve above sea surface temperature in central and east equatorial Pacific, together with change in atmosphere circulation, such with weak trade wind and shift of the tropical rain pattern. El Nino is not simply ocean warming event. It is a coupled ocean atmosphere phenomena. Under normal conditions, strong east trade wind push warm water to the West Pacific, cold water in East Equatorial Pacific. During the El Nino, trade wind weak and warm water move eastward, and the Central East Pacific become significantly warmer than normal. This warming then feeds back to atmosphere, altering tropical convection and global circulation pattern. Why does this matter? Tropical Pacific is a major source of the heat moisture for atmosphere. When El Nino develops, it influences weather pattern far beyond the Pacific through atmosphere-tide connection. Historically, El Nino has been associated with drought in some regions, heavy rainfall and flooding in other areas. Shift tropical cyclone activity, heat wave, and disruption to the agriculture and water resource. It is important to emphasize El Nino occurs in one ocean basin, but its influence is global. Its impact can reach across Asia, Australia, Africa, America, even Polar region. Because this far-reach effect, El Nino is one of most close monitored climate phenomena in the world.
Okay, so now that El Nino has formed, the big question is strength. So what are the key signals scientists are watching to determine whether this becomes a strong or very strong event? And what are the main uncertainties at this stage?
Well, the first signal scientists watch is the evolution of the surface temperature in central and east equatorial Pacific. If warming continuing over coming months, likelihood of a strong El Nino increase. A commonly used measure is the Nino 3.4 index, which measures temperature over Central East Equatorial Pacific. The second signal is the amount of the heat stored behind the ocean surface. Often before a major El Nino develops, warm water accumulates in the West Central Pacific. If this subsurface heat continues to move eastward, reach the surface, it provides additional fuel for the event. The third signal is the behavior of atmosphere. Scientists closely monitor trade wind, tropical convection, cloud pattern, atmosphere pressure change. A strong El Nino requires not only warm ocean temperature but also a strong atmosphere response. When ocean and atmosphere reinforce each other through the Birkin feedback, warming can continue intensify. Another factor receives increased attention is the role of the three ocean basins. The research from my group and others have shown Indian Ocean, Atlantic Ocean can influence development of the major El Nino event. Some strong El Nino like 1997,
Mhm.
98, 2000, 1996, and 2015 and 16 was associated with the favorable condition for all three tropical oceans. Therefore, scientists also monitor how Indian Ocean, Atlantic Ocean develop in the coming months. The main uncertainty is the climate system is highly nonlinear. Small change in wind, ocean temperature, and tropical convection can alter the event. In addition, different climate models may agree El Nino will persistent, but still differ on intensity. So while the current signal may point toward the significant event, there's still uncertain regarding the eventually peak intensity.
And actually, earlier forecasts were already pointing toward a possible super El Nino. But what does that actually mean? Like, is there a strict scientific definition of what makes an El Nino event super?
Super El Nino is a widely used term, but it is not a universally strict scientific definition. Generally, scientists use the term to describe strong El Nino events that stand out from historical record because of their magnitude and global impact. In practice, even like 1982, 83, 1997, 1998, 2015, and 16 are commonly regarded as a super El Nino. This event produces large surface temperature anomaly in tropical Pacific and generally climate impact over global ocean and land. Different institutes may use different definition. A common benchmark is Nino 3.4 region anomaly larger than 2 degrees C during mature phase of the event. But this is not a single international accept cutoff. Therefore, super Nino should be viewed as a useful term rather than formal scientific classification. Another important consider is the climate change. Today, the ocean is warmer than there several decades ago. As a result, strong El Nino now develop on top of the high temperature baseline. This can increase likelihood of the record-breaking heat, marine heat wave, coral bleach, and other climate extreme. In this sense, even if future El Nino have similar strengths to the past major event, the impact may be amplified in warmer climate.
Yeah, and you mentioned some years earlier this century and last century, but actually people are also referencing the 1877 to 78 El Nino when talking about a potential super event today. So can you walk us back to that period? Like, what do we know about what happened back then?
The 1877-78 El Nino took place during Great Drought, one of the most extensive drought events over global scale. Historical and climate reconstruction indicate widespread drought across part of the Asia, Africa, South America, and other regions. The event coincided with crop failure, famine in India, North China, and part of Brazil and part of Africa. Scientifically, 1877-78 event is difficult to evaluate because direct ocean observation were sparse compared with today. We rely on ship observation, reconstruct surface temperature, pressure record, rainfall record, and historical documents. Studies suggest it is one of strong El Nino event in historical record, but we must be careful about the ranking because data uncertainty. What makes the 1877-78 El Nino so important is not just the intensity. It occurs when society had a very limited ability to predict, prepare, and respond to climate extreme. With weak transportation network and widespread dependence on agriculture, strong climate event was able to trigger major social economic consequences.
Yeah, the situation has certainly changed today. So now between globalized food markets, satellite tracking, advanced power grids, are we resilient enough to absorb a similar event, a potential super El Nino, or are there new vulnerabilities that we perhaps haven't accounted for?
We should not have same level of the female mortality today because the world has a much better early warning system, satellite observation, seasonal forecasting, emergency response, green reserve, transportation, and international aid. They are major advances, but it would be mistake to say we are fully safe. Today, vulnerability are different. Food markets are globalized, so a drought in one region can affect prices elsewhere. Power systems are more advanced, but they are also more exposed to heat wave, high cooling demand, hydropower shortage, and storm disruption. Cities are larger, coastline are more developed, and supply chain are highly connected. Climate shock can now propagating through trade, energy, insurance, and public health. In other words, mountain society is more resilient in some way, but also more interconnected. A strong El Nino today would probably not reproduce 1877 disaster, but it could still produce serious compound risk, especially if drought, heat, flood, crop loss, and energy stress occur at the same time in multiple regions.
Okay, and actually, if we zoom in on China during that same 1877 to 78 period, the country was hit by a multi year catastrophe known as the Northern Chinese famine. To what extent was that linked to the El Nino event?
North China famine occurred during 1876 to 79 and was associated with severe multi-year drought in North China. El Nino likely contributed to the drought by altering large-scale atmospheric circulation and weakening moisture transport into North China. Historical climate studies show North China drought risk can increase associated with El Nino, although relationship is not a one-to-one. Famine itself also shaped by social vulnerability, agriculture dependent on rainfall, limited irrigation in many areas, poor transport, weak relief capacity, and political economic stress. Therefore, we would see 1877-78 El Nino was an important climate contributor, but it was not only cause of the famine. Disaster emerging from combination of extreme climate event and vulnerable society. For China, the lesson is El Nino can change probability of the region drought or flooding pattern, but human outcome depend on preparedness, water management, grid security, and disaster response.
Yeah, so while a famine on that scale is highly unlikely today, does the 1877 experience offer any clues about the kinds of climate risks that El Nino can pose to China?
Yes, the 1877 experience remind us El Nino can affect China through multiple pathways. One pathway is drought risk in North China, especially when summer rainfall is suppressed. Another pathway is flooding risk in part of the South Central China, especially during mature phase and decay phase of El Nino, when circulation anomaly can favor persistent rainfall. It is also remind us impact can last longer than peak of the El Nino itself. El Nino event may peak in winter, but China's flood and drought risk can strongly affect in the fall, spring, and summer. Water management, agriculture planning, heat health preparedness, power system planning therefore need consider full El Nino life cycle, not only months when ocean index is highest.
Yeah, and one phrase that often comes up in discussion of El Nino impact on China is South flood, North drought. Can you explain what that means? And are we going to see similar pattern this year?
South flood, North drought is a simplified description of the one common El Nino related pattern in China. During some El Nino event, South China can experience enhanced rainfall and flood risk. North China may experience reduced rainfall and drought risk. This can happen through changes East Asia monsoon and West North Pacific subtropical high moisture transport from South China Sea and West Pacific. But it is important to see this is not a law of nature. China rainfall depends not only on El Nino but also on the West North Pacific, Indian Ocean, mid-latitude circulation, intra-seasonal oscillation, and local land-ocean outer-land atmosphere feedback. For this year, risk of the south-west north dry tendency should be taken seriously, especially if El Nino strengthens into winter and affect following warmer season. But exactly regional pattern must be updated using seasonal forecast and real-time monitor. I would avoid seeing with certainty China will see classic pattern everywhere. A better message is El Nino raise the probability of the pattern, but regional forecast should guide decision.
Okay, and actually, China's National Climate Center has also said the developing El Nino may peak in autumn and winter. So, as we move from the development phase toward the peak phase, What signals should be watched most closely for China?
When El Nino developed toward the peak in fall and winter, seven key signals scientists will watch closely assess the potential impact on China. First, we will continue monitor the intensity and the space pattern of warming in tropical Pacific. Not all El Nino are same. Secondly, we will close watch change in West North Pacific atmosphere circulation. El Nino often induce atmosphere anticyclone over West North Pacific, which can modify moisture transport toward the China, and this circulation feature play a key role to decide the rainfall pattern over China. Third, sea surface temperature conditions in Indian Ocean and the Atlantic Ocean are also important. Research has shown this ocean basin can either amplify or modify atmospheric response to El Nino. Because the climate systems are interconnected across the ocean, monitor the evolution of the full three tropical ocean can improve understanding of potential impact on China. For China, fall and winter impact often include change in temperature and rainfall pattern. Historically, many El Nino has been associated with wetter than normal conditions in part of South China during fall and winter and spring. Although exact pattern vary from event to event, some regions may be experience increased flooding risk, and other regions may be face a period of drought. The key message is attention should be focused not only on how strong El Nino become, but also on how atmosphere responds. Atmosphere circulation over West North Pacific and East Asia will largely determine how El Nino influence China. As we move toward fall and winter, this circulation signal may provide more direct information than sea surface temperature alone.
Yeah, and we are already seeing unusually wet conditions in parts of China, especially the southern part of China since spring, and also I think India saw unusually high temperatures in spring. So are these early fingerprints of the developing El Nino?
It could be partly related, but I would be caution. Usually, weather conditions can result from many factors, including monsoon surge, position of West North Pacific subtropical high, tropical convection, typhoon activity, mid-latitude system, and soil moisture feedback. A developer El Nino can influence larger scale circulation, but early seasonal rainfall anomalies are rarely caused by El Nino alone. Scientific approach is to ask whether observed rainfall pattern is consistent with the circulation anomaly from El Nino develop. For example, change in low-level wind, moisture transport, convection over tropical Pacific and West North Pacific sub-anticyclone anomaly. If these signals are present, then El Nino may be part of explanation. I would say El Nino can be one ingredient of this current weather prediction, but we should not attribute every heavy rainfall even directly to El Nino. Attribution require careful analysis, observation, and model experience.
Okay, and another area receiving attention is energy demand, because some southern provinces have already experienced unusually early peaks in electricity demand this year. So, to what extent could a hotter El Nino year place additional stress on China's power system?
A hot El Nino year can stress the power system in several ways. First, high temperature increase air conditioning demand. especially in South and East China, where population density and economic activity are high. Second, if heat coincident with drought, hydropower availability can be reduced in some basins, leading to a supply-demand mismatch. Third, high temperature can reduce efficiency of the thermal power plants. Fourth, heavy rainfall and flooding can also damage infrastructure, meaning the risks are not limited to heat drought. They also include extreme weather conditions. El Nino can increase the probability of global and regional temperature anomaly because the tropical Pacific release heat to the atmosphere and shift atmosphere circulation. In a warming climate, high baseline temperature means the same El Nino can trigger more extreme heat events. For policymakers, the key is to prepare compound stress, heat plus high demand, drought plus low hydropower, flood plus disruption, and possible region mismatch between the supply and demand.
So, if we look at the full life cycle of an El Nino event, from its development in the spring to its peak in the winter and its eventual weakening the following spring, how should policymakers be thinking about the risks at every stage?
The policymaker should think El Nino as a life cycle of the change risk during developing stage of spring and summer. The main task is early warning. Agency should monitor Pacific system temperature, subsurface heat content, wind, rainfall, and model forecast. This is also the time to review water management rule, agriculture planning, emergency supplies, energy demand, and public communication. During the growth and peak phase of the El Nino, usually in fall and winter, the global teleconnection becomes stronger. Countries should be monitor drought risk, flooding risk, flood market, and energy stress. For China, winter and early spring circulation anomaly can also set a stage for later rainfall pattern. During decay phase in the following spring and summer, risks do not simply disappear. In East Asia, some of the strong rainfall impact can occur after the El Nino peak because the tropical Indian Ocean and the West Pacific can maintain atmosphere anomaly. This delay effect is one reason the life cycle matter too much.
Yeah, and also I think you mentioned earlier that a warmer climate is also influencing El Nino and its impacts because the event is now operating on top of a much warmer ocean baseline. So can you explain more on that? Like, how does that change the risk that we're facing today? And does this also complicate the forecasts that scientists are making?
A warmer climate change risk in several ways. First, ocean atmosphere now starting from warmer baseline. This means El Nino of the same relative intensity can produce higher absolute temperature and more heat extreme. Secondly, a warmer atmosphere can hold more water vapor. So, when circulation favors rainfall can be more intense. Third, warming can amplify marine heat wave, coral bleach risk, and heat stress on people and ecosystem. It may also affect El Nino itself, although exact change in answer amplitude, frequency, and flavor remain active research topic. Some studies suggest super El Nino and extreme rainfall response may become more likely in warming climate, but there's still uncertainty across the model. Forecasting is also more complicated because background climate is changing. Historical analogs such as 1982-83, 1997, 1998, 2015-16 are useful, but no past event occur on today's exact ocean baseline. This is why I emphasize three ocean interaction is important. The Pacific, Indian, Atlantic Ocean are all warming, and then interaction may play important role in determining intensity of El Nino and the pattern and its global impact.
So, in a warming world, are we moving from isolated climate shocks toward overlapping and compounding risks where heat waves, droughts, floods, food prices, and energy demand, they all kind of reinforce one another?
Yes, this is one of the most important messages. In the past, we often discuss climate hazard one by one drought, one flood, one heat wave, but in a warming climate, this risk increase crazily overlap. A strong El Nino can raise global temperature, shift the rainfall, affect crop, warmer ocean, stress the coral reef, change energy demand, and this impact can occur in different regions at the same time, and then connected through the trade and supply chain, price, and public health. For example, drought can reduce crop production, hydropower. Heat can raise electricity demand and damage human health. Flood can disrupt transport and infrastructure. If seven of these happen together, the total risk is larger than individual hazard.
Okay, Professor Wang Chunzai, thank you so much for joining us today.
You're welcome.
And that wraps up this edition of Climate Watch. You can find more episodes on your favorite podcast platforms. Just search for Climate Watch and hit subscribe. Don't forget to leave us a quick review or share it with a friend. You can also email us at radio@cgtn.com with your questions or feedback. And stay updated on the latest climate stories with our Substack newsletter, Climate Choices. I'm Zhao Ying. Thank you so much for listening. See you next time.